Hello, this is Dr. Marion Carroll, and we wanted to begin with the second part of Lecture 3. And in this part we wanted to discuss the periodic table. And I said I would bring an image, and we have one right here. This is a little dated. As you can see, we only have 114 elements listed here. However, up to this point, we have several filled in here, and it actually goes to 118. So 15, 16, 17, 18. That was as of 2010. And this one, let's see if I can see when this was printed. No, I don't have a date for this one, but it is an earlier version. But our main focus is on these elements here at the top. We're not going to worry about the lanthanide series or the actinide series in this basic general chemistry discussion, but we will talk about the different parts of this periodic table. First thing, let's note, let's bring in our discussion we had previously on atomic structure and the subatomic particles. I'll make a larger image of one of these squares, and I think I'll put, let's see, what could I put in here? I'll put bromine in here, Br for bromine. And if you recall, the atomic number for bromine would be at the top, and you can see bromine is here under chlorine. It's one of the halogens. This group here is referred to as the halogens or halides. This is group 7A, and we'll talk about these groups here. But in the bromine, the atomic number is 35, and you'll find that at the top. And we try to maintain a standard. All of the periodic tables are set up in this manner. The atomic mass or atomic mass units, sometimes it's referred to as the atomic weight, is located here below the symbol, and the atomic mass, or AMU for bromine, 79.904. You'll find that below the symbol. Okay, so our atomic number is, do you remember? It's the number of protons and since all of these elements in the periodic table are represented as neutral, this is also the number of electrons. Remember, protons are positive, electrons are negative, and so we have 35 electrons, giving us a total of 70 subatomic particles. Now, we also learned in our previous part that the atomic mass unit for protons is 1. Okay? Equals 1 atomic mass unit. And that of an electron is what? Essentially 0. Because it is very, very small. It's 10,000 times smaller than proton. And so the mass of the bromine can be found in the number of protons. All right, but the atomic mass unit is 79.904. So there is a mass that's unaccounted for. And how do we get that? Well, we take that total atomic mass unit and we subtract 35, which is the atomic mass protons, and what do we get? Okay, we can fill in these. This is 4 and this is 4. So that means that we have 44 atomic mass units unaccounted for. And where do we find those? That's the number of neutrons that bromine has. Because the number of neutrons plus the number of protons, because their atomic mass unit is 1, their number is equal to the atomic mass unit, 35. Electrons, even though there are 35 to give us a neutral molecule, their atomic mass unit is essentially 0. 0 AMUs. So when we add up 44 and 35, we get a total of 79, which is close to the atomic mass of bromine. Why is it 79.904? Well, we'll talk about that later. Because of the presence of bromine isotopes. Those are molecules or elements of bromine that have different characteristics, but they are the same. They are bromine. So they have, actually the characteristics that they possess is a difference in the number of neutrons present. So this number can vary. I don't know right now off the top how much bromine varies, or what is the percentage of different isotopes, or how many different isotopes, but I can certainly find out that information. And they would vary in the number of neutrons, giving an average value for the atomic mass, 79.904. Okay, well, this same process or this same structure applies, of course, to all the elements in the table. We begin over here with our group 1 elements. Group 1, with the exception of hydrogen, are all what are called alkali metals. Okay, they're very, very reactive with water. And those include lithium, sodium, potassium, rubidium, cesium, francium. The reactivity increases as we go up this way. And so lithium and sodium being very, very reactive in water, I should say, very reactive in water. Group 2, I'm sorry, this is group, what did I call it? Group 1A, so it should be 1A. Group 2A consists of elements that belong to the alkaline earth metals. Okay, the alkaline earth metals are in our group 2A, the alkali metals 1A. These groups continue being numbered across. However, these metals here in the center, these are all referred to as the metal class. We begin with 3B, and it goes all the way to 7B. We're 7B here with manganese. And this group has very similar characteristics, and they're all grouped in 8B. And then we begin again with 1B and 2B. And these indications follow the actual number of electrons that are found in the outer shell of these elements. There's 1 electron in the p orbital. In the group 3b, there are 2 and 4b, 5b, there are 3, 8b changes slightly so that we have 2, 7, and 8 electrons, 2 in the orbital s, and 7 and 8 in the d orbitals. And we'll talk about those orbitals structures later. And so what you want to remember is that from 3b all the way to 2b, we're talking about metals. Okay, we have alkali metals, alkaline earth metals, 1A and 2A respectively. The class of metals, 3B to 2B, and we have the non-metals, which are begin over here with boron, and they include boron, silicon, arsenic, and we have tellurium and acetylene. And so everything on this side of this diagonal, these are what are called nonmetals. So what are the characteristics of nonmetals? They're brittle, non-conductive. Okay. Characteristics of metal. The metals tend to be, let's go up here, malleable. That is, they're able to bend easily. There's that. There it is. Malleable. And also ductile. These are two typical descriptions of the metal class. Ductile meaning that you can stretch them to wire. Alright. Along this diagonal, real quickly, we have aluminum, boron, silicon, germanium, arsenic, antimony, and so forth. These along this diagonal are referred to as a class of metalloids. that have both characteristics of metals and nonmetals. Okay, so this is as far as we're going to go with this. We'll look more carefully at this as we continue. All of these families, we didn't really talk about 3A all the way to 8A for the Nobel gases. But these are our nonmetals. These are our metals, alkaline earth and alkali in our periodic table. Thanks for listening, and we'll return with lecture 4.